Let's do some examples with the heat equation. So I have example number 1, how much heat is needed to raise the temperature of 100 grams of water from 30 degrees Celsius to 90 degrees Celsius. And I'm also given the specific heat of water is 1 calorie per gram degrees Celsius. So I want to know how much heat. So I'm going to put Q is equal to question mark, just so that I know what I'm solving for. And then I know that I'm raising the temperature of 100 grams of water, so that's our mass. From 30 degrees Celsius to 90 degrees Celsius. So what that tells me is that the change in temperature, which is final temperature minus initial temperature, will be 90 degrees Celsius minus 30 degrees Celsius, which is 60 degrees Celsius. And then I'm also given that the specific heat of water, which is C, is 1 calorie per gram degrees Celsius. Now notice this unit of specific heat. What this tells me is that I'm going to get my answer, my Q, in the unit of calories, all right? So I know my equation is Q equals MC delta T. Solving for Q here, we get mass is 100 grams. C, our specific heat is 1 calorie per gram degrees Celsius, and then our change in temperature was 60 degrees Celsius. So we get a heat of 6,000 calories. So that's how much heat, how much energy is required to raise the temperature of that water. Now let's do example number 3. We're just skipping number 2 apparently. How much heat is needed to raise the temperature of 100 grams of aluminum from 30 degrees Celsius to 90 degrees Celsius? So this is a different substance, but it's the same mass and it's the same temperature change. And here they give us the specific heat of aluminum is 0.921 joules per gram degree Celsius. Now remember, this specific heat is going to be different for every substance. So something with a higher specific heat requires more energy, more heat in order to undergo the same temperature change as something with a lower specific heat, which would require less heat to undergo that temperature change. So let's see how much heat aluminum requires, and then we can see if it requires more heat or less heat than water did, with the same mass and the same temperature change. So again, we're looking for Q. I have a mass, again, of 100 grams. The delta T, the temperature change, it's still going from 30 to 90. So my delta T is 90 minus 30, which again is 60 degrees Celsius. And then C, I'm given this time in joules per gram degrees Celsius. So at the end, in order to compare it to water, we'll convert that joules into calories, because remember, they're both units of heat. So again, heat, Q is equal to MC delta T. Q is equal to 100 grams times C, our specific heat, of 0.921 joules per gram degree Celsius. And then our change in temperature is, again, 60 degrees Celsius. So we get 100 times 0.921 times 60, which ends up being 5,526 joules. But again, if we want to convert that to calories, so we can compare it to water, I start with 5,526 joules. I know that in 1 calorie, there are 4.184 joules. That was our conversion factor. All right, notice how in this conversion factor here, I put joules on the bottom because I want to be able to cancel joules out and convert that number to calories. So we get 5,526 divided by 4.184. And that tells us that we need 1,320.75 calories in order to heat aluminum, the same amount of aluminum, the same temperature change. So what this tells us is that because we need less heat than we needed for water in order to undergo the same temperature change for the same amount of substance, so the same mass of substance, because of that, we know that aluminum has a lower specific heat capacity than water does, because it requires less heat to undergo the same temperature change for the same amount of material. All right, example number 4, which really it's example number 3. What mass of water undergoes a temperature change from 25 degrees Celsius to 95 degrees Celsius when it absorbs 14,644 joules of heat? And now we're given the specific heat of water in joules per gram degree Celsius. So it's 4.184 joules per gram degree Celsius. So here we're looking for mass. So mass equals question mark. We undergo a temperature change, delta T, from 25 to 95 degrees Celsius. So final temperature is 95 degrees Celsius minus initial temperature, which is 25 degrees Celsius, which ends up being 70 degrees Celsius. That's our temperature change. And it's a positive 70. And it's absorbing, so we have a positive Q of 14,644 joules. Now I also know that my specific heat capacity of water is 4.184 joules per gram degrees Celsius. So if you're given heat, Q, and your specific heat capacity, you want to make sure that those units match up as well. So we can see that our heat is measured in joules and our specific heat capacity is joules per gram degrees Celsius. So you want to make sure that those match up because they don't, like I've said before, they have several different units for specific heat capacity. So again, we know that Q is equal to mc delta T. I'm solving for m here, so I'm going to divide both sides by c delta T to get m by itself. So we get mass is equal to Q divided by C times delta T. Plugging in our numbers, mass is equal to our heat added, which is 14,644 joules, divided by the specific heat capacity, 4.184 joules per gram degree Celsius, times the change in temperature, which is a positive 70 degrees Celsius. So when you're doing this on your calculator, you want to make sure that you put parentheses around that denominator. So I have 14,644 divided by, open parenthesis, 4.184 times 70, close parenthesis, and then we get my answer, which ends up being mass of 50, not kilograms, sorry, grams. I'm so used to physics, we always measure everything in kilograms, but this is 50 grams of water, which is also 50 milliliters of water because 1 milliliter of water is equal to 1 gram because it weighs 1 gram. Not true for every liquid, just water. Okay, again, pay close attention to how you're doing this in your calculator. Like I said, you want to put parentheses around the denominator here because if you don't, then you would basically just divide 14,644 by 4.184 and then you would multiply that whole thing by 70. So you have to be really careful about that. All right, last but not least, example number 5. How much heat is lost when 150 grams of water is cooled from 80 degrees Celsius to 60 degrees Celsius? So here, again, we're measuring heat, and then I know that my mass is 150 grams of water. I know that my delta T is, we're cooling this water down now. So final temperature is 60 degrees Celsius minus initial temperature, which is 80 degrees Celsius. So our delta T is actually a negative 20 degrees Celsius. And then I know that C for water is 1 calorie per gram degree Celsius. So I know that I will get my heat in calories. Now here I get Q is equal to mc delta T. So heat is equal to 150 grams times C, 1 calorie per gram degree Celsius. And then I'm multiplying by a negative 20 degrees Celsius. So I can see here that since I'm multiplying by a negative number, I'm going to get a negative number. And that makes sense because sorry, I was plugging it into my calculator and I lost my train of thought. Because we're losing this heat, right? Heat is lost. Heat is being, it's going out into the surroundings. So we're losing heat. The system's losing heat, and therefore our heat should be negative. Q should be negative. We get a negative 3,000 calories for this process.